Hi, in this video we're going to prove some statement to do with any two possible odd integers or any two possible even integers. And notice I didn't use the word consecutive. In previous videos on this skill, we've seen how to prove something to do with like consecutive odd numbers or consecutive even numbers. Consecutive just means next to each other. So for example, like 7 and 9 are two consecutive odd numbers because they're next to each other. But this time it says we want to prove something about any two odd integers. And specifically it's saying we want to prove algebraically that the difference of the squares of any two odd integers is always divisible by 4. Now let's just remind ourselves how we represent any two possible odd integers. If they were consecutive odd integers, then they differ by 2. And remember, we can represent any possible odd number using, for example, 2n plus 1. The reason that works is because if n represents a whole number, 2 times any whole number will always be even. So 2n represents any even number because we can represent any even numbers 2 times something. And then if you add 1, any even number plus 1 will be an odd number. So every odd number can be expressed as 1 more than an even number. And if you had 2 consecutive odd numbers, then, well, if you had 7, you get the next one by adding 2. So if you had 2n plus 1 as an odd integer, you get the next one by adding 2, right? But if you want any two possible odd integers, not necessarily consecutive, you just use different variables. So if you've got one odd integer as 2n plus 1, then to get another odd number that's not necessarily related, just any other possible odd number, could be the same, could be different, we do, instead of 2n plus 1, we do 2m plus 1. You've got to use a different variable, but you might as just well use n and m. Right, okay, so prove algebraically the difference of the squares of any two odd integers. Well, any two odd integers could be represented as 2n plus 1 and 2m plus 1. And it's saying that the difference of the squares of these, so if we square each, and we're doing the difference of those squares. Okay, so we've represented the difference of the squares of any two odd integers, and we need to show that this is always divisible by 4. How are we going to do that? Well, firstly, we're going to expand these brackets. So let's just write each bracket twice, because when you square a bracket, you times it by itself. And let's do this. We do each thing in the first bracket times each thing in the second. 2n times 2n is 4n squared. 2n times 1 is plus 2n. We've got 1 times 2n, which is 2n. And 1 times 1, which is plus 1. And remember, when you expand any brackets, you're subtracting that. So we're subtracting the 2n plus 1, 2n plus 1. We need to make sure it's in a bracket first. We'll see why in a second. So we then do 2m times 2m, which is 4m squared, 2m times 1, which is plus 2m. We got plus 1 times 2m, which is 2m, and 1 times 1, which is plus 1. Now let's just tidy up. We got 4n squared, 2n plus 2n is 4 lots of n, plus 1, and then minus, then this bracket, let's tidy up. We got 4m squared, 2m plus 2m is 4m, plus 1, like that. And now, the reason we had that bracket is because we're not just subtracting the 4m squared, we're subtracting every term in this bracket. So we're going to have 4n squared plus 4n plus 1. And we got minus the 4m squared, but we're also minusing the 4m, and we're also minusing the 1, like that. Now, to show this is always divisible by 4, any number that's divisible by 4 is 4 times something. So we've got to write it in the form 4 multiplied by something. Could be a bracket. So let's just kind of simplify this a bit. We've got 1 minus 1, they cancel. So we're left with the 4n squared plus 4n minus 4m squared minus 4m. Now, can we write this in the form 4 times something? Well, we just need to factorize out the 4. And then we say, well, 4 times what is 4n squared? What's n squared? 4 times what is 4n? It's plus n. 4 times what is minus 4m squared? It's minus m squared. And 4 times what is minus 4m? It's minus m. So we've shown that our result, the difference of the squares of any two possible odd integers, can be written as 4 times by something, which is guaranteed to be divisible by 4. So you say just to be explicit, just because we're trying to prove that this thing is always divisible by 4, it's 4 times an integer, we should use the words which is divisible by 4, just to make that explicit. And our proof is complete.